What's up, everyone? Today we're going to do an interesting problem where we are going to convert integers into their Roman numeral representations. So we're going to write a function, and that function is going to take in an integer, and it's going to return a string, and that string is going to be the Roman numeral. So we have a couple examples here. Obviously, if we convert 1 to a Roman numeral, we just get I, and if we convert 4, we just get IV. But we also have this more complicated example where 49 actually converts to XLIX, because you have 40 plus 9. And so what we want to do is take in an arbitrary integer and then return the Roman numeral for that. So let's dive right into the problem. The first thing that we probably want to do is just refresh our memory if we're not super strong on Roman numerals. So this is not a kind of question where you would be expected to know offhand all of the representations for all of the different numbers. It's probably a reasonable expectation that you would know at least the basics. Like these first two examples, I would probably expect you to know. But the third gets a little bit more complicated. So it's totally valid for you to ask your interviewer at least to give you several examples and to explain to you in a bit more depth how the number system actually works. So we can just look briefly at these examples. This is just 1 to 100 and then a couple other numbers thrown in there. And you can see some patterns emerge, right? You can basically, obviously the Roman numerals work that you add all of the values unless you have a lesser value preceding a greater value, and then it's subtractive. But there are only very few cases in which you actually subtract numbers. So there's this case 4, you subtract 1 from 5. And then there's 9, you subtract 1 from 10. And then there is, again, here with 19, you're subtracting 1 from 10. And then you don't do any until you get to 40, which you subtract 10 from 50. And then you subtract 10 from 100, and then 100 from 500, and et cetera, et cetera. So what we can see here is that we're actually only subtracting for certain pairs. So if we go back, we know that we can have IV, we can have IX, we can have XL, we can have XC, we can have CD, we can have CM. And that's it, right? Those are the only cases in which we're actually subtracting. Otherwise, all we're doing is just adding stuff up. And so this is something that you would want to go through with your interviewer and just to make sure that you understand how this works. Another thing that we may want to ask our interviewer about is the range of the numbers, right? Because we don't know, it doesn't really make sense if there are negative numbers, for example. So what do we do in that case? Another thing that you might notice is that in none of these numbers do you ever repeat a symbol more than 3 times. So generally, rather than repeating a symbol more than 3 times, you do like the subtractive thing. But in this case, we are assuming that our maximum digit or our maximum value is this 1000, the M. And so that wouldn't really make sense. The highest number that you can have would be MMM, DCCC. What would it be? Actually, DCD. You could have basically 3,999 without repeating a digit more than 3 times. And so we probably want to also check that we can limit our maximum value to 3,999 because otherwise it's not going to make a lot of sense. And there have been additions to the Roman numeral set so that you can do higher numbers, but we're going to assume that in this case our digits only go up to M. So now that we have a bit of a better understanding of Roman numerals and what it is that we're doing, let's talk about how we're actually going to solve this. And I think that the best way to look at a problem like this is to start by doing it by hand. Because it's basically we're doing a brute force solution and we're doing it by hand. And that's going to give us a better understanding of how we're actually going to do the conversion. So let's start with, this example. So we're going to start with the integer. We have 49. And we want to convert this to Roman numerals. So the first thing we're probably going to do is we're going to see, this is divisible, or this contains the number 40. Like it's less than 50, so we're not going to have L. but it's greater than 40, so we are going to have XL. And that's going to be the start of our number. And then we're going to see that after you subtract 40, the remainder is going to be 9. And so 9 is obviously IX. And then we get the number pretty easily. We can also take another example, like let's take 2017, for example. We would see, oh, there's 2000. So 2000, we're going to get MM. And then 17. So 17 is less than 20, but it's greater than 10. So we're going to have X. And that's, we're going to subtract another 10. So now we have 7 left, and 7, we're going to subtract 5, and then we're going to subtract 2 ones, and we end up with 0. So we end up with MMXVII for 2017. So basically what we're doing is we're finding the maximum value that we can remove from our number each iteration, and then doing that and appending them all together. So it's a greedy algorithm, and that seems pretty reasonable to me. So I think that we can actually just go ahead and code this up. And so what we're going to want to do first is we're going to want to track have all of our possible digits that we can convert to, and then we're going to want to have like a mapping of the digit of the like M, X, D, L, whatever it is, to the relative number. And then we're also going to want to have those in sorted order from greatest to least, because we're going to want to first try and subtract 1,000. And then if we can't subtract 1,000, we're going to try and subtract 500 or whatever it is. So the other thing that we're going to do is we are going to have to take into account these. So there are only 6 of these, but they're the 6 examples where a number is actually, you have to represent it by, you're either representing it subtractively or you're considering it to like just say this 2-digit number represents 4. So what I'm going to do is I'm going to track these in addition to all of the single digit ones, since there's only a fixed number of them, and that way it's just going to make life easier, and I'm not going to have to come up with another way to keep track of these, of which ones can be subtracted from which other ones. So hopefully this will make sense more when we start coding. So first, what I'm going to do is I'm just going to create 2 parallel arrays. So I'm going to create an array of the like Roman numerals, and then I'm going to create an array of their respective values, just because I think it's going to be a little bit easier this way. So we're going to create, in this case, we can do a static final array, and this is going to be of the numerals. So what I'm going to do is, as I said, I'm going to include both the single and double ones. So I'm going to have M, I'll have CM, D, CD, C, XC, L, XL, and I'm obviously doing these in descending order. X, IX, V, IV, and I, right? And then I'm going to do the same with the numbers. So I'm going to say private static final int array, and I'm going to call this values is going to be equal to a new int array of 1,000, 900, 500, 400, 100, 90, 50, 40, 10, 9. Oops, missed a comma there. 10, 9, 5, 4, 1. Right? So we have the same number of elements in both arrays, and so index 3, for example, is going to refer to CD in numerals and 400 in values, so they're going to map nicely to each other. And then I'm going to define my function, which is going to be called, I'm going to call this integer to Roman, so I'll define a public method string. It's going to return a string, which is the Roman numeral. and it's going to take in an int, which is just going to be called value. So the first thing that we can do here is to do our sanity check, and we decided that our number has to be between 1 and 3,999, right? So we can say if value is greater than 399 or value is less than 1, then we can just, in this case, let's throw an exception, although you can ask your interviewer what they want you to do. But I'm going to throw an illegal argument exception. And then otherwise, we're basically going to initialize an empty string, and then we're going to do this greedily, right? So we're going to start with 1,000 and try and remove 1,000, and then if we can't, we're going to try and remove 900, and then 500 and 400, et cetera, et cetera. So what I'm going to do is actually create a string builder for this. So you don't actually really have to use a string builder here because it's a small enough example, but it's certainly the proper way to do it is to use a string builder. And it's another thing you can also tell your interviewer, probably if I was writing this in production, I would use a string builder, but for now I'm just going to use a string because it's easier, but I'm going to use a string builder just to be good in this case. So I'll call it numeral. It's going to be a new string builder. And then what we're also going to do is I'm going to do a while loop. So I'm just going to do while value is greater than 0, and I'm going to subtract from that. But I also want to keep a pointer into these arrays so that I know where I'm at. Because I never want to I don't want to subtract like 500 and then subtract 1,000. I only want to subtract 1,000 first and then 500, then 400, then 100, et cetera, et cetera. So I'm going to keep a pointer and basically iterate through until, I might end up at 1, and then I'll just subtract 1 each time until my value ultimately gets to 0. So I'm going to say int I equals 0, and then while value is greater than 0, I'm going to say, so if value minus values of numerals I, values I, then I'm going, if that's greater than or equal to 0, then I want to do that, right? So if it's not creating a negative number, if I can remove that from my value, I want to remove it. And so I'm just saying that, I'm trying to remove the biggest value that I can. If that's greater than or equal to 0, I say numeral dot append, and this I'm appending to my string builder, right? Numerals I, which is the corresponding Roman numeral for the value that I subtracted. I'm going to append that, and then I'm going to say value minus equals values I. Right, so I'm going to subtract the value and then keep going. And otherwise, I just have to increment my pointer. And then all that's left after that is to return the string. So I'm going to return, and remember, since it's a string builder, I need to convert to a string. So numeral.toString. And that's all we have to do. So it's not a super complicated thing once you understand what it is that you're trying to do. But this is a good example of a problem where the code may be easy, but you have to have a pretty good idea of what you're doing first. And so doing the brute force solution and going through and actually solving it by hand will make it a whole lot easier when you get to actually trying to solve the problem. So let's go through a quick example. Let's try 49. So we're going to pass in 49, and then we're going to start with this empty string, and our string is between those two numbers, so we're fine. And we're going to initialize I to be 0, and then we're going to say, so value is 49. So value is 49, and then numeral is this empty string. So we're going to say that, all right, so value is greater than 0, value minus value 0. So value 0 is going to be, whoops, this should be 1,000. So value minus 1,000 is going to be obviously negative, what is it, 951. So we are going to skip down to here and I++, so I is now 1. Values minus 900 is still negative. Values minus 500 is negative. 400 is negative. 100 is negative. 90 is negative. 50 is negative. But 40 is not negative. So we're going to say 49 minus 40, and we're going to come to here, is greater than 0. And so numerals, the append, we're going to take numerals 7. So what is it? 0, 1, 2, 3, 4, 5, 6, 7. So XL, and we add XL to our string. And then value is equal to values minus 40. So we're going to end up with 9. Now we come back here and our value is still greater than 0. Value minus values I is going to be negative, so we're going to increment I again. Then 9 minus 10 is still negative, but 9 minus 9 is 0. So that is going to be greater than or equal to 0, and so we append numerals 9, which is going to, in this case, be this IX. So we append IX, we subtract 9 from value, and we get 0, and then we break out of our loop. And so, as you can see, this works pretty well, and it works the way that this number system is designed. We can use this greedy algorithm pretty easily. So hopefully that makes sense. In terms of runtime for this problem, it's going to be proportional to the size of the number, right? So we're going to just have a linear runtime. Although in this case, it's also going to be capped because since we're capping the size of the input, there's like an absolute maximum runtime that you're going to get. So that's kind of nice in this case, but otherwise it's going to be linear. And so that's about it. So let me know in the comments below or on the blog if you have any questions, and otherwise I will see you guys again soon.